Hello friends, myself Rajendra Mahajan presenting my video on linear differential equation. Solve differential equation d cube plus 3d square plus 3d plus 1 into y is equal to e raised to minus x, where capital D stands for the operator d by dx. Here y is dependent variable, x is independent variable. And then to obtain its solution, first of all, we have to write down the auxiliary equation. Auxiliary equation means equating this polynomial to 0, we get a d cube plus 3d square plus 3d plus 1 equal to 0. A cubic equation. Means when we try to solve it for d, we are getting 3 roots of this equation. Rewriting this, it is a cube plus 3ab square plus 3a square b plus b cube, means nothing but a plus b whole cube. Therefore it is d plus 1 whole cube is equals to 0. Equating to 0, we get d is equals to minus 1 and minus 1. Here roots are real and repeated. A root is repeated 3 times, and as it is repeated a real root, therefore the complementary function is given by or obtained by. As it is real and repeated root, we can write that as c1 plus c2x plus c3x square, as it is repeated 3 times, into e raised to m1x, e raised to the value of root is minus 1, therefore minus x. Equation number 1. This is the required complementary function. Then we require to find out pi by inverse operator technique. It is 1 upon f of d, means it is d cube plus 3d square plus 3d plus 1 into e raised to minus x. The term on the right hand side is e raised to minus x, e raised to ax type. The rule for that is we have to replace d by a. A is here the coefficient of x, that is minus 1. Therefore everywhere we have to replace d by minus 1, and therefore we get minus 1 cube plus 3 into minus 1 square, 3 into minus 1 plus 1, which we have to operate on e raised to minus x, and therefore it is 1 upon minus 1 cube is minus 1, minus 1 square is plus 1, into 3 we get plus 3, minus 3 and plus 1 operated on e raised to minus x. If we take a sum of all this, 3 minus 3 and 1 minus 1, we get that 1 as 0. 1 by 0 means case fail. And as case fail, we go to the next step as x into 1 upon differentiating this with respect to d. Its derivative is 3d square. Derivative of 3d square is 3 to the 6d, and derivative of 3d is 3. Derivative constant term is 0, which we have to operate on e raised to minus x. Again replacing d by same a is here minus 1, we have x 1 upon 3 into minus 1 square, 6 into minus 1 and plus 3, which we have to operate on e raised to minus x, and therefore it is x minus 1 whole square is plus 1 into 3, that is plus 3 6 minus 6 we get 0, therefore 1 by 0 operated on e raised to minus x. Again case fail. As case fail second time, we go to the next step as x into x, that is x square, into differentiating this with respect to d, we get that derivative as 6d plus 6 operated on x e raised to minus x. Again replacing d by a is here minus 1, we have x square 1 upon 6 into minus 1 plus 6 operated on e raised to minus x. 6 minus 6 we get once again 0, therefore 1 by 0 e raised to minus x. Third time case fail. We go to the next step as x cube 1 upon differentiating this with respect to d is derivative is 6, derivative of this constant term is 0, and which we have to operate on e raised to minus x. And as we get a non-zero term in the denominator, we stop here and we call this as equation number 2, that is pi. And then complete solution is equation number 1, that is cf, plus equation 2 pi. And complete solution is always for the dependent variable. Here the dependent variable is y. CF is C1 plus C2x plus C3x square into e raised to minus x. This part is called as a complementary function part, plus this pi. Pi is x cube divided by 6 into e raised to minus x as the required solution. Therefore, this is the case number 1, shortcut type, when the function is in the form of e raised to ax. And whenever it is in the form of e raised to ax, we have to replace d by a to obtain the pi. One more I will discuss in my next video, or the problem for case number 2. Please like my video, share it, as well as subscribe to my channel, and to receive the notification, please press the bell icon. Thank you. Thanks for watching.